Hi everyone, today's notes are going to be about operations on functions and composite functions. So we've already dealt with the operations of functions, so this is just a quick little review, f plus g of x. So we're going to have f of x plus g of x. Our f of x is up here, negative x squared plus 6, and we're going to add that to our 2x squared plus 3x minus 5, which is our g of x. And then we're going to go ahead and actually just combine like terms. So when we combine like terms on this one, we have the negative x squared, 2x squared. That's going to get us our x squared. Those are combined. We only have the 3x, and then 6 minus 5 is 1. So once we actually perform the operation, then we are good to just combine like terms when we are adding. On this one, we want to be careful because it's a subtraction. This is where I put the parentheses. You can also put parentheses around this too if you wanted, but that's not going to do anything by distributing the plus sign. But this distribution of the minus sign here will actually affect this. So this is now going to become a negative 2x squared, a negative 3x, and a positive 5. I'm going to combine it with these like terms here. I have a negative x squared and a negative 2x. So negative 3x squared now. And then I have a negative 3x, that's the only one, and then a positive 11. Okay. So again, subtraction, make sure it's distributed to that last term, whatever the back term is there. This is just multiplication, so I'm going to be multiplying x squared plus negative x squared plus 6 times 2x squared plus 3x minus 5. Again, I'm distributing all of these, and we'll have to combine like terms. So negative times a positive will be a negative x to the fourth, negative 3x to the third, positive 5x squared. And then I have my distribute these now. So 6 times 2x. I'm just going to write it down here so I have room. I'm actually going to line it up with the ones it goes under if it does. So I have 6 times 2x, which is 12x squared. Then I have 6 times 3x, which is 12x. And then 6 times negative 5 is a negative 30. Sorry, I'm writing it over here. Now I'm going to combine like terms. So my like terms, all I have is that negative 2x to the fourth, highest term, negative 3x to the third. 5 and 12 is 17x squared. And then negative 12x minus 30. Plus 30, plus 30. That should be a plus 30. No, it was negative. I was right. Negative times a positive is a negative. Okay. And then our last one, this is going to be the same except for I am adding something a little bit new to this thing you haven't seen where g of x cannot equal 0. So we're going to be figuring out the domain for our function here. So if I have negative x squared plus 6 divided by 2x squared plus 3x minus 5, we want to see if these things factor. My leading coefficient here is negative, so I'm going to take out a negative 1, x squared minus 6. Don't think I have a factor for that one. And then for here, I'm going to factor the denominator as well. So when I go to do that, I'm going to do my AC method. I have 3 terms. 2 times negative 5 is negative 10. 3 at the bottom, I'm going to have 5 minus 2. So I'm going to use the AC method, 2x squared, write my new b values, get my GCF here. So I have just an x, so 2x plus 5, and then a negative, and then I have a 2x plus 5 again. And then that means that my factors are x minus 1 and 2x plus 5. So when I have that, we are just looking for, nothing's going to divide out here, so this will be my final answer. But what I'm looking for our domain is when basically this cannot equal 0. So what I look for is basically setting those each of those denominators equal to 0 because I don't want them to actually end up being 0 times anything because we can't divide by 0. So for our domains, I'm going to set this factor equal to 0 and this factor equal to 0 and solve for x. So by adding 1, I get x equals 1. So x cannot equal 1. That's going to make this become 0. And I'm going to subtract 5 here. Get 2x equals negative 5. Divide by 2. X cannot equal a negative 5 over 2. So write the little cannot. That's our domain. They cannot equal negative 5 over 2 or a positive 1. So that's the thing I want to practice. This is the new part of this. So we're going to give the restrictions for the following rational functions. Hence, we're going to set the denominators equal to 0. So here, I can, if you want to factor out the negative, then you can, because it's the, that positive value there. If not, it's just going to be having to divide by a negative eventually. So I'm just going to set this one just so you guys can see what I mean by that. Subtract 2. Negative 5x equals negative 2. Divide by negative 5. X cannot equal, negative divided by negative is going to be a positive 2/5. So that is our domain restriction for that one. Then we have our x squared minus 9. Remember, this is a difference of squares. So it's going to be x plus 3, x minus 3. So again, I'm going to set each of these equal to 0 to find my domain restrictions and solve for x for each of these. So x cannot equal a negative 3 and x cannot equal a 3. Okay, and then our last one, I'm going to actually have you guys do that one. I will check for you guys in class when I do this, and I will make sure that you guys are right on your domain restriction for that number 3. And now the new stuff that we have on our notes, we are going to be, this is where we have our composite functions. So on our composite functions, this little key point right here, this means of, so f of g of x, so it's written like this. We are going to be plugging in g of x into our f of x equation. So let me show you what that actually looks like. So this is our g of x, this is our f of x. So instead of seeing an x here, like we do the g of x, we're actually going to plug in the actual equation. So I have 2 times 4x. I just plug this in for that x on that case. So 2 times 4x minus 5. Then what we're going to do is we're actually going to multiply. 2 times 4 is 8x minus 5. That is as far as I can go. That's as far as I can simplify, but I just plugged in that g of x for this f of x. The other type of composite function with an actual value that you're going to be seeing, you could be given any value here, and we're going to plug that into g of x first, and then whatever we get for g of x, we're then going to plug into f of x. So if I have my, let me show you here. So work with the inside first. G of negative 1. So I'm going to plug that into my g of x equation. 4 times negative 1, we get a negative 4. So that was when I plugged in negative 1 for g. Now I have to plug this negative 4 in to my f of x. So now I have f of negative 4. I'm plugging in negative 4 for x. Negative 4 times 2, we get negative 8 minus 5 more. We are going to end up with our negative 13. This is our final solution for the f of g of negative 1. Okay, so that's how we would write that on this values here. So when we go to practice some of these, I'm only going to do some of these for you guys. We have different values now, so be careful. There's f of x, g of x, and h of x now. So the couple ones, I'm only going to do a couple, and I want you guys to try the rest of them. Okay, so the ones I'm going to do are actually 5 and 6 for you guys. So g of x, I'm working with first. I'm going to plug that g of x into my h of x equation. And I'm going to plug it into all of the x's. So that negative 2x plus 1, I put everything in parentheses that you are actually substituting in. Negative 2x plus 1 again. So I'm just, if you see this, I have an x. Oh, okay, x, negative 2x plus 1 is where my equation goes, then I had a squared. Plus 6 times that g of x again, because that's where I have an x again, and then plus 8. Now we're going to do these operations. So remember that this negative 2x plus 1, it's squared. We have to write this out 2 times. And then we also get to distribute that 6. So let's distribute these two first. Negative 2x times negative 2x, we get a positive 4x squared. Negative 2x times 1 is a negative 2x, and plus 1. We're going to combine these like terms first. So this will equal a 4x squared minus 4x plus 1. And then I'm going to now distribute this. So we have a 6 times negative 2 is a negative 12x, and 6 times 1 is a positive 6. So I am going to, and then we have our plus 8 back here. So I'm going to combine these like terms and then bring it down here with the rest of this. So for here, actually we could just combine all like terms right here. So I don't have any more x squared, so 4x squared is it. Then I have a negative 4x and a negative 12x, so we have a negative 16x. And then we have our 6 and our 1 and our 8, so we end up getting our 15. And that is our final equation. And then I'm going to do number 6 for you guys. That'll be my last problem. So we're going to plug 2 in for the x for our g of x. So we have our g of 2 equals negative 2 times 2 plus 1. I'm going to go ahead and simplify that. Negative 2 times 2 is a negative 4 plus 1. We get a negative 3. Now I'm plugging this back in for my g of x again, but it's going to change the number. So now I have g of negative 3 for each of those x's, or the 1x, and negative 2 times negative 3 is a positive 6. We're going to add the 1, and we end up getting 7. And that's for our g of g2, when that equals that. Okay, so go ahead and practice 1 through 4. We can go over answers in class. If you have any questions, comments, anything in there about the notes that you even just want to have to remember for you for taking quizzes and tests, that'd be helpful. Go ahead and make a note there. And if not, I will see you in class. Thanks.